This is Mrs. O'Neill for AP Chemistry, Chapter 16, Section 1, Acid-Base Equilibria. At this point, you should understand the concept of equilibrium. And in the past chapter, we talked about equilibrium reactions in general. Now, these are going to be specific equilibrium reactions only dealing with acids and bases. And weak acids and bases, because strong acids and bases go to completion. So these are only for weak acids and weak bases for those reactions. So at some point, please find 692 and look up those key terms. Pause the video, read this over. Ha ha ha, hopefully you got that. So let's first review naming acids, and if you need even more understanding, go back to chapter 2, I believe, when we did naming of ionic compounds, covalent compounds, and acids. So just quickly, here's our HCl. We can break that apart into the cation and the anion. So acids are really named after its anion that it's produced from. So in this case, we have hydrogen with one other element, so that anion would end in chloride. If it ends in ide, we're going to call it hydrochloric acid. If that anion was ClO3, let's say, then that's a polyatomic ion, and that ClO3 would be chlorate, and since it's chlorate, it would change to chloric acid. If it was ClO2, then that name would be chlorite, and chlorite would change to chlorous acid. So again, let's look at these practice problems. So pause the video, try to do the naming the acids and also writing the acids. Hopefully you got that information, those answers. If not, please come see me or talk to somebody in class to get some more practice. So in section 1, we're just going to talk about acids and bases as a brief review. So your objective is to understand an Arrhenius definition of an acid or a base. Now, there's going to be 3 different labels of acids and base: the Arrhenius acid and base, the Bronsted-Lowry acid and base, and the Lewis acid and base. The Arrhenius acid and base is the most simple and the one that you probably will understand because it's one we've talked about forever. An acid always starts with an H, so it has H plus ions. A base always ends in OH, so it has an OH ions. So that's the simplest. Then we're going to talk about the Bronsted-Lowry acid and base and what that definition really refers to. And at the very end of the chapter, we're going to talk about Lewis acids and bases. So at this point, again, pause the video, fill in the blanks, and then play to hear my words. Yes, acids usually taste sour. They conduct electricity. They are strong or weak electrolytes, so strong acid versus weak acid. This is something to keep in mind when they react with metals. They're going to form that hydrogen gas, which you might have done either in Chem 1 or in AP Chem labs. When they react with hydroxides, or when acids react with a base, it's going to form salt and water, and that's called a neutralization reaction, and we'll talk in more detail about that as well. And if you use litmus paper, it's going to turn it red. So there's just some information about why or how we taste sour. Properties of bases: they do taste bitter, they feel slippery, just like soap. Those are usually your basic side. They can be strong or weak electrolytes. And again, when they react with an acid, they form salt and water, a neutralization reaction. When you use that litmus paper, they turn blue. So I like to remember blue for base. So many items contain acids or bases. Some you probably would recognize right away, and some you're like, oh, I never knew that that was acidic or that was basic. So examples of acids would be your citrus fruits, and even your teas and coffees are usually more on the acidic side. When you take Tums or antacid, it neutralizes your stomach and calms it down if it's upset, and that's a base. Also, this calcium hydroxide, kind of used as that's called a component of mortar. It's kind of like the glue that holds bricks together. Most things that have calcium in it, I'm going to say, are more on the basic side. Milk of magnesia is a base, used as an antacid. Bases are usually hazardous when taken internally, but the low solubility of the milk, magnesia, makes it safe to use. So we want to remember that a lot of things that we do take internally might not be great for us, but we take it at such low dilution that it's okay. So here's our guy Arrhenius and some information on him. So what did he come up with? Well, he said in an aqueous solution, an acid is going to produce H plus ions, or what we're going to call this hydronium ion. And we're going to explain a little bit more in detail how this hydronium ion is produced. And bases produce OH ions. So again, that should make sense. Most acids formula start with an H. So when it breaks apart, you have that H plus. When bases break apart, it breaks apart into that OH minus, or it ends in that OH hydroxide ion in the formula. So again, that's your acid versus base. So here's an example of an Arrhenius acid. Again, hydrochloric acid is going to break apart into hydrogen ions and chloride ions. And again, that hydronium ion as well. So that's why it's an acid, because of that H plus. Here's an example of an Arrhenius base. We have sodium metal plus water yields base and hydrogen. So let's look at that reaction. Here's our base, but if it says it's at aqueous, then we know that it's going to also break apart into Na plus and OH minus. So we have sodium hydroxide as a base because of this hydroxide ion. Oh, it's a base, if that's how you want to try to remember it. Okay, see you in class.